Welcome back. Today we're going to discuss Lesson 5.1, Model Factors. We're starting Chapter 5, which is all about factors, multiples, and patterns. So today I'd like you to open up your journals. Please write down 5.1, Model Factors, and we're going to start at the beginning with a definition of the word factors. A factor is a number that is multiplied by another number to find a product. Pretty simple. We've been working with these all along. Today we're going to work with whole numbers. And I'm going to add that every whole number has at least two factors. Itself and 1. Now, many numbers can be broken into factors in different ways. So today we're going to show you how to do that. So let's try this. We want to find the product of 12. Oops, how do I... So let's think about what are two numbers that we can multiply time together to get to 12. Well, first of all, we know that 1 times 12 equals 12. What's another pair of numbers that I can multiply together? And these are whole numbers. What's another pair of whole numbers that I can multiply together to get 12? Okay, let's try this. 2 times 6 equals 12. Good job, superstars. How about one more? Can you think of one more set, one more pair of whole numbers that I can multiply together to get 12? You're right. 3 times 4 equals 12. Can we think of any other whole numbers that we can multiply together to get 12? Can I multiply, 4 times 3? But isn't 4 times 3 the same as 3 times 4? We're going to review the commutative property here. I think 4 times 3 and 3 times 4 is absolutely the same. So let's just not add 4 times 3 here, okay? I think we found all the factor pairs of 12. So right here, we have created factor pairs for 12. Now, boys and girls, what we want to do is we want to create a model to show each one of these factor pairs. So here we go. So boys and girls, I've switched over to grid paper, graph paper, so let's take a look. We're going to count these out. So the first factor pair that I'm going to use as a model is 1 times 12. So I'm going to start here, I'm going to put a 1 here, and I'm going to count my boxes. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1. Okay, let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I now have 12 boxes here. So 1 times 12 equals 12. Pretty simple. Looks a lot like our area models. I think there's a reason for that. Let's go on. We're going to try 2 times 6. So let's see if we can do it this time. 2. 1, 2 times 1, 2, 3, 4, 5, 6. Let's draw the bottom line here, and let's put our factors. 2 times 6 equals 12. Let's try one more. Let's try 3. 1, 2, 3 times 1, 2, 3, 4. 1, 2, 3, 4. Let's draw our line. This is times 4. 3 times 4 equals 12. Easy breezy. We have just created our 3 factor models for the product of 12. All right, let's try another one. All right, we're going to try it again, but this time we're going to try a larger product. And because we're trying a larger product, we're not going to use the graph paper. We're just going to draw a rectangular area model, just like we've done in the past. So let's try the factors of 18. So what I want to find out are what are the numbers that when I multiply them together, these whole numbers, that give me 18. Okay, first things first. 1 times 18 equals 18. You're absolutely right. Can I multiply 2 times any number? Oh, sure. 2 times 9 equals 18. Good job. All right, how about 3? Can I multiply 3 times any number? 3 times, oh, you're getting good, 6 equals 18. Can I multiply 4 times any number to get 18? No. I think we found all of our factors. So let's go ahead and try and create our factor models for 18. First, I'm going to start here. I'm going to draw 1. 1. I'm going to draw out a rectangular box along my paper, nice and long. 1 times 18 equals 18. This time I'm going to take my 2. 2 times 9 equals 18. You'll notice I made this box about half the size of the first box because 9 is half of 18. Let's go on here. Why is it doing that? 3. 3 times what, boys and girls, equals 18? You're right. 3 times 6 equals 18. So the factor pairs of 18 are 1 and 18, 2 and 9, 3 and 6. Or another way is to write the factors of 18 from the least to the greatest. The factors of 18 are 1, 2, 3, 6, 9, and 18. Let's try another one. All right, this time, boys and girls, we're going to try and find the factors of 20 without using graph paper. So here is 20. 20 equals what 2 whole numbers? Let's see. We know that 1 times any number, those are 2 factors of 20. 1 times 20 is 20. How about 2? You're right. 2 times 10 equals 20. 3 times any whole number? How about 4? 4 times 5 equals 20. We know that 5 times 4 equals 20, but because those are the same factors and we're just reversing the order, we can use the commutative property, so we don't need to write that multiplication sentence. Let's go ahead and draw the model now for the factor pairs of 20. Our first factor pair is 1 times 20. So I'm going to make a nice long lean box. 1 times 20 equals 20. My next box is going to be 2. I'm going to make my box about half that length because 10 is half of 20. 2 times 10 equals 20. Good job. My third box, because I have a third factor pair, will look something like this. 4 times 5 equals 20. So the factor pairs of 20 are 1 times 20, 2 times 10, and 4 times 5. The factors of 20 from smallest to largest are 1, 2, 4, 5, 10, and 20. Now I'm going to ask you to do some practice problems. So boys and girls, you are going to find the factors of 24, and then you're going to draw the models. You're going to then find the factors of 32, and then draw the models. And then our third practice problem will be to find the factors of 36, and then draw the model. All right, we'll see you tomorrow.